Alright, sorry about my voice. I'm going to do the best that I can making this video for you so that I don't have to strain my voice in class. Plus, then you'll be able to use this later as needed for extra help. So we're starting a unit on quadratic functions. Every quadratic function is going to graph as a parabola. Quadratic functions are always going to have an x squared in those. That is what we have been factoring for the most part. Excuse me. One way to graph is to pick values for x and plug them in to find the y. So if we plug these in, you're going to get 4. I'm just squaring this number. 4, 1, 0, 1, and 4. And if you go and place those on the graph, then you will get these points. So go ahead and graph this. Pause this video anywhere that you need to keep up. I'm going to go through it as quickly as I can. You are trying to connect this with a smooth curve. That is awful. But so try to connect that with as smooth as you can. Remember, your domain is your x values. So in this case, that is all reals, funky r that we've made. The range is your y values. Your lowest y is a 0, so y is greater than or equal to 0. Okay, there are different formats that you will see of quadratic functions, and here are those 3 different formats. Standard form, this should look very familiar to you. Most of the equations that we factored were in standard form. Excuse me. So an example of this would be like 2x squared plus 3x plus 5. Okay, in vertex form, it's going to look like this. So where a, h, and k are going to be constants, they're going to be numbers. So it could be something like 2x minus 4 squared plus 3. So a, h, and k are all going to be constants. And then intercept form looks like this. P and q are constants. And also the a. Again, I'm just going to repeat that down here. So this could be something like 3x minus 4 and x plus 2. Something like that. So down here, you are going to determine if these represent, if you graph them. So you're not going to graph them yet. But just by looking at the equations, would the graph or the equation, so graphs down here, equations here, would it be quadratic? So based off of these formats, what I'm going to suggest that you do is, like when you look at this one, does it look like any of these formats? And it doesn't. And as a matter of fact, you should know that this one is linear. So on this one it says determine if they're quadratic. You would say no, and an explanation could be linear. If, like this one, you look at it, and this looks like standard form, so this one would be yes, and your explanation could be that it's a quadratic in standard form. So standard form of a quadratic. Let's just say quad. Okay, so you go through and do the rest of these. Like I said, if it matches up with one of these formats, you can say yes and say y. And then looking at your graphs, the first thing we set up top is that a parabola is what a quadratic function graphs into, and the graphed one up top, so I know that you'll know which ones of these is a quadratic and which one isn't. And looking at my notes, I'm not sure if yours printed okay, but my notes don't have this line on it. So look at this and then decide which ones are going to be quadratic. Alright, go ahead and flip the page. Alright, on this page, it is telling us about the parts of parabola and how the equation is going to help you determine those parts. So the value of a, remember a is the coefficient of the x squared term. If it is positive, your parabola is going to open up. So this one is an example of one that is opening up. If it opens down, a is going to be negative. So this would be an example of like 2x squared plus 2x plus 2. This one would be maybe negative 3x squared plus 2x plus 4. So you're just looking at this value of your leading coefficient. If it is positive, A is opening up. If it is negative, A is going to, the parabola, is going to open down. So by opening down, we mean its graph would look like that. So opening up and opening down. Okay, the vertex is the highest or lowest point. On this example over here, it's right here. So it's going to be where your parabola changes directions. So it will be right here. On this one, it will be right here when it's opening down. So that's why it's the highest or lowest point. It's on the axis of symmetry, which is our next vocab term here. Okay, so the axis of symmetry is the vertical line that divides the parabola into two equal points. So a lot of times we'll have you graph a dashed line down through your graph to help you. Sorry about the jet cameras. So that's your vertical line that divides the parabola. It's a line of symmetry. The axis of symmetry. That's always going to go through that vertex. It is always going to be halfway between x-intercepts. Okay, so here's an x-intercept and here's one. So this one's really easy. Halfway in between them is 2. You can always average the x-intercepts if you need to, if it's not quite as clear. Okay, so it's halfway in between, so you're going to just count on the graph. Or you could always add these together. This one is further divided by 2 is 2. X-intercepts is where the parabola crosses the x-axis. Remember we talked about this in the last chapter. They're called solutions, roots, or zeros of the functions. So again, the way you write the axis of symmetry, I'm going to go back to this one for a second. The equation for the axis of symmetry would be x equals 2. So that's your equation for this axis of symmetry. And the y-intercept on this one, I'm starting to pass to it out, is going to be 0, 3 in this case. And we notice that that's the c value. So if we're graphing this, 3 is going to show up in your equation right here at c. So 0, c, 3 is going to show up right here in your equation. Alright, coming on down here. We're doing a couple different things on matching at the bottom here, and I'm going to do a little bit and have you work through the rest of the matching. First thing you are doing is you're looking at the equation and filling in this information. So the A is going to be this first term, so the A is 2. Since A is positive, this parabola is going to open up. The y-intercept comes from your C value. So the y-intercept is going to be negative 1 from that. And then you can match that up with a graph. So you're looking for a parabola that opens up. So the value either A or D. Which one of those has a y-intercept that would be negative 1, not A. So this would be D. And you will continue that and matching it with those three. Down here, what you are doing is when you are looking at a graph. So you're looking at this graph. The graph opens up. You can fill in this part maybe before you finish these. Maybe you can do it in later. Looking at this graph, you know that this A is going to be positive. We don't know positive or what, but we know it opens up. And on this graph, we know the y-intercept is a positive 1 right there. So fill out the rest of this page. And when you've gotten that filled out, you can pause here, fill that out, or go on to the next page and you can come back and finish filling that out later. So we're going to learn how to graph some of these. First, we can do it without a graphing calculator. We will be using a graphing calculator, this test, when we get to the end of the chapter, we'll have both a graphing calculator and a non-graphing calculator. Excuse me. Okay, so we have a graph. We need to find out all of this information from that graph, and then we need to fit which equation could be the equation for this parabola. So the axis of symmetry, remember that is always halfway between your x-intercepts. So you could count 1, 2, 3, 4, 5, 6. There are 6 numbers in between, so 3 over. That would be right here. We can also look for your vertex. And your vertex is either your lowest or your highest point. So that is where x is -1. Your vertex is again right here. So that is at -1, -9. Your x-intercepts are -4 and 2. And remember, this can only be as -4, 0, and 2, 0. Like this both ways. Your y-intercept is -8 to start here. That one would be 0, -8. And remember that is the C value. A is positive or negative. Since this parabola opens up, we know that it is going to be positive. Since this parabola opens up, it has a minimum. Okay, so this would be the minimum. When we talk about maximum and minimum, we're talking about the y values. So the lowest point on this graph is here. Anytime it is positive, there will be a minimum, because it's going to be the lowest part of the graph. The domain goes on forever in the x directions. The range, the lowest part on the range, is going to be down here at -9. So that is what's that is greater than or equal to -9, because it's going up this way. Okay, so now we should be ready to check our primary equation. So if you look at your C value, it's supposed to be -8, so it cannot be that or that. And then we said that our A has to be positive, so it can't be that one or that one. So there is our equation. And then this, remember, is function notation. We use the function, this is usually f of x. So we're trying to find this value when x equals 1. You can do that in 2 different ways. You can either go to the graph, and for 1, and you go down and see that y is -5. Or you could also plug it into the equation that you chose and make sure you're right. So if I plug in -5 for x here and here, if I plug in 1 here and here, so that would be 1, and that would be 2, 1 plus 2 is 3, and 3 minus 3 is also -5. So you can verify that you chose the right equation for the graph, or you can look at this on the graph. Alright, so you go ahead and try to finish numbers 2 and 3, and then we will display the answers for those, and make sure that you